Today I'll share with you just a few more helpful properties for simplifying expressions with exponents. To begin, let's start by reducing these fractions. Remember that 15 over 20 can be reduced. If we divide those both by 5, that gives us an answer of 3/4. And in this example, 2 times 2 times 2 times 3 is, let's see, 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, so that's 24. And on the bottom, 2 times 2 is 4, times 7 is 28. And 24 28ths, I could divide out 4 from each of those. That would give us 24 divided by 4 is 6, and 28 divided by 4 is 7. And then here at the end, 6/7 times 5/8 times 14/15. That's 30 times. There's got to be an easier way. And in fact, there is. This first example you can't get that one too much easier. But in this second example, I didn't have to do 2 times 2 times 2 times 3 to get 24, and 2 times 2 times 7 to get 28. In fact, this first one is very easy to simplify if you understand a very important rule. That is, if you have the same factor on top and on bottom of a fraction, you can cancel it out. So I have a 2 on top and a 2 on bottom. I can cancel those out. And I've got another 2 on top and another 2 on bottom. I can cancel those out. What's left is 2 times 3, which is the 6 that we got in our final answer, and 7, which is the denominator of our final answer. Over here, these aren't quite broken down completely, but I could break these down a little bit. 6 is the same thing as a 2 times a 3. 5 is already a prime number. It can't be broken down any further, but 14 is the same thing as a 2 times a 7. We're going to learn in later chapters that this process is called finding the prime factorization of a number, that is, breaking it down. 8 is the same thing as 2 times 2 times 2. And 15 is the same thing as 3 times 5. And if I start crossing out factors that I see on top and bottom, 2, and I'll cross out a 2 over here, and here's another factor of 2, and another factor of 2 can get canceled out, a 3, and a 3, and I see a 5, and a 5 can be canceled out, and in fact a 7, and a 7 can get canceled out. I see that on top I've canceled out everything. If that ever happens, that means we've reduced it down to the identity for multiplication, which is a 1. And on the bottom, the only factor that was left was a 2. So our original answer, 6/7 times 5/8 times 14/15, if I multiplied all those together, I would have ended up getting 1/2. So here's that rule that I mentioned before. Factors that are in the numerator and in the denominator will cancel themselves out. So in this example, 6 to the 5th times 6 to the 4th, a lot of people will make the mistake of canceling out the 6's and writing this as maybe 5/4 or something like that. You need to realize that these are not factors in of themselves. These are bases. And so I need to look at factors. If I rewrote this, either on paper or in my head, I would see that I've got 5 factors of 6 and 4 factors of 6 on the bottom. And if I start canceling them out, I'm left with 1 factor of 6 in the numerator. And so that's 6 over 1, or just plain old 6. Another example. On top, I've got a total of 1, 2, 3, 4, 5 factors of 2. And on the bottom, I've got a total of 8 factors of 2. If you imagine with me, 5 pairs of 2's would cancel out, and there would be left on the bottom 2 times 2 times 2, or 2 to the third power. Remember, if everything on top gets canceled out, we would write a 1, and so that's the same thing as 1/8. If you got lost in some of that, actually write out all the 2's and all the 2's down here and start canceling them out, and you'll see that this is what we end up with. And in fact, I might need to do that with this expression because of all the different variables. X squared is the same thing as x times x. Over here, 9xy squared, this 2, remember, only applies to the thing right next to it, the y. And so y squared is the same thing as y times y. And on the bottom, y to the 5th means y times y times y times y times y. And now I can start canceling things out. There's one x on the bottom that can cancel out one of the x's that's on top. And then there's 1, 2, 3 y's on top, can cancel out with 3 of the y's that are on the bottom. But now I don't see any common factors. And so now it becomes a matter of simplifying the top and the bottom. The top, number-wise, we've got a 2 and a 9 as factors. So 2 times 9 gives us 18. I still have x and another x left over as variable factors. So I would write x squared. And then on the bottom, y times y reduces to y squared. And so here's our final answer. Anyway, the helpful properties that are associated with this is that when you've got powers that have the same base on top and bottom, like the 6 to the 5th and 6 to the 4th example we had, one shortcut is that you can subtract their exponents. This would be helpful if you had some ridiculous expression like a to the 100th divided by a to the 30th. I wouldn't want to draw out 100 a's on top and 30 a's on the bottom and start canceling them out and then have to count how many a's were left over. I can go straight to the answer by imagining the 100 on top and the 30 on the bottom. 30 of them can cancel out, which leaves 70 on top. Another way I like to think about that is to think about who wins. Are there more factors on top or on bottom, and by how much? Likewise, if we've got a variable, another helpful property that we can use is that if we have an entire group and maybe even a fraction that's raised to a power, that power can be distributed to all the exponents within the group, including those on top and on bottom. So a over b, that fraction raised to the m power, can be simplified as a to the m over b to the m. Let's see how these properties are used in some examples. 2 thirds raised to the 4th power. We could write this out as 2 thirds times 2 thirds times 2 thirds times 2 thirds, or we can use the property we just talked about and distribute this 4 to each of the objects inside. And so that becomes 2 to the 4th over 2 to the 3rd, over 3 to the 4th. And this is just a bunch of 2's. This is just a bunch of 3's. There's no common factors from the top and bottom for us to cancel out. And so we can just simplify the top by multiplying. 2 times 2 times 2 times 2 is 16. And on the bottom, 3 to the 4th power, 3 times 3 times 3 times 3 is 81. And so that's our final answer, 16/81. In this example, we could begin by distributing the 3 to each of these exponents. But another thing that I like to do is, if it's not too difficult, I might simplify things before I distribute this power. If I notice in this fraction here, 3y over y squared, that's y times y in the bottom. I could begin by reducing by canceling out a y on top and a y on the bottom. This inside cleans up to just negative 3 over y. And now that is raised to the third power. And so now I can distribute that exponent to all the objects inside here, including the negative sign. Remember, a negative raised to a odd number means I'll have one negative sign left over when they all start canceling out. So my answer is going to be a negative. And then 3 to the third power and 3 to the y gives us 3 to the third on top and y to the third on the bottom. And since there's no common factors, since I've already reduced the inside as much as I can, to simplify this is now just a matter of simplifying the top and the bottom. The negative sign is still there, but 3 to the third is 27, and y to the third is just y to the third. Notice, just for the sake of argument, if we had distributed the exponent to everything, we would have had negative times negative times negative, 3 to the third power, y to the third power on top, and on the bottom, y to the sixth power. And we could reduce this using the who wins by how much sort of thinking. There's 3 y's on top and 6 y's on the bottom, so the bottom y's win by how much? By 3. And now the 3 negatives cancel themselves out to give us a negative answer, and 3 times 3 times 3 is 27. Now, for some people, the top approach might have been easier, and for others, this bottom approach might be easier. The key is that either way, we simplified to the same answer. There's a few more examples. X to the 10th over x to the 3rd raised to the 4th. Maybe I'll just quick distribute that. 4 times 10 means there's 40 factors of x on top. And on the bottom, x to the 3rd raised to the 4th power means there's 12 factors of x on the bottom. And here it's important to remember that there are 40 x's on top. We drew them all out, and 12 x's on bottom, and they start canceling themselves out in pairs. Who wins? Well, the top is certainly going to win. By how much? By whatever 40 minus 12 is. So 40 minus 12, that's the same thing as 28. Notice if we had reduced, that is reduced ahead of time, 10 and 3, there's 7 more on top than there is on bottom. So that's x to the 7th raised to the 4th power. And we get x to the 28th again. For this example, maybe I'll try to reduce as much as I can ahead of time. On top, there's 1, 2, 3 factors of x, and on the bottom, there's only 1 factor of x. So the x's on top win by 2. Looking at the y's, there's 1, 2, 3 factors of y on top, and there's 4 factors of y on the bottom. So the y's on the bottom win by 1. And then number-wise, 2 times 9 is 18 over 6 reduces to 3 on top and 1 on the bottom. And that whole thing is now reduced as much as possible, but it needs to still be raised to the 3rd power. And so this 3 can be distributed to the factor of 3, the power of x squared, and the factor of y in the bottom there. And so that gives me 3 to the 3rd on top, or 27. X to the 6th on top, 2 times 3. And on the bottom, y to the 1st times 3 is y to the 3rd on the bottom. And one final example, which looks completely disgusting, but just to show you that we can do this if we approach it in small chunks. Maybe the first thing I'll do is take this factor and rewrite it. Remember, if you've got a whole fraction raised to a negative exponent, it might be easier to rewrite that as the reciprocal raised to the positive fourth power. And so that would be the same thing as writing 2u squared on top and m cubed on the bottom. And that whole thing is now raised, instead of a negative fourth power, to a positive fourth power. So now it might be useful to use the distributive property on all of these groups. So that first fraction is 2 to the fourth power, and u to the 8th power, 2 times 4, and on the bottom, m to the 12th power. A fraction times another fraction is just, we're going to extend this fraction, have one big fraction. M squared raised to the 3rd power is the total of m to the 6th, and then s to the 3rd power, and u to the 6th power. On the bottom, we've got u cubed and m cubed. And then our final fraction that's on the end here is just m to the 20th over 24s and u to the 6th. And what I probably will do here is start to simplify things one term at a time, or one factor at a time. If we look at the numbers, I've got 2 to the 4th on top and 24 on the bottom. 2 to the 4th is 16 and 24, and that can be reduced easily enough. Divide both sides by 8, and we've got 2 thirds. And so number-wise, I'll end up with a 2 on top and a 3 on the bottom. Now maybe I'll look at the different letters. There are 3 letters in total. There's m's, s's, and u's. If I look at the m's, there's a total of 6 factors of m here and 20 here, so 26 factors of m on top. And then there's 12, 15 total m's on the bottom. And who wins that battle? The m's on top win by 11, so I'll write m to the 11th on top. Then the next letter in the alphabet, I guess, would be the s's, and so there's 3 factors of s on top, and there's 1 factor of s on the bottom, and so that works out to the s's winning by 2. And finally, there are 6 factors of u on top plus 8 factors of u from the beginning. There's 14 factors of u in total. And then down here, there's 3 factors of u and 6 more factors of u. That's 9 factors. So 14 on top and 9 on the bottom. That works out to u to the 5th on top. So 2 m to the 11th s squared u to the 5th all over 3, or another way of writing that without having a big fraction would be just write 2 thirds times m to the 11th s squared u to the 5th. So tackling this thing one step at a time was the key, every step of the way using some sort of helpful property, or if we needed to, writing everything out.